The Chatelier's principle tells us how a reaction will respond to disturbances to its equilibrium. So say I have this reaction again. So this is the gas phase reaction. Say I've achieved equilibrium. What happens if I input more iodine into the reaction vessel after I've achieved equilibrium? So I put more iodine into the reaction. Now I have too many reactants, and the reaction will have to go forward to relieve the additional amount of iodine so that the reaction can achieve equilibrium. The same thing will happen if I input more chlorine after it's reached equilibrium. Now I have too much of a reactant, so the reaction will have to respond by going forward, producing more product in order to relieve the additional reactant and to achieve equilibrium. On the other hand, say I add more product to the reaction vessel at equilibrium. Then the reaction would have to run backwards to relieve the additional amount of product that I added. Conversely, I can say take away some iodine. So I take iodine away, so now I don't have enough reactant. And the reaction will have to run backwards to replace the reactant that I had taken away. So this is how a reaction can respond. Now let's consider the reaction of nitrogen and hydrogen in the gas phase to form ammonia. So say we're in the gas phase and we have the equilibrium constant in terms of concentration. So we've got concentration of ammonia squared divided by the concentration of nitrogen and the concentration of hydrogen cubed. So this is in the gas phase. We have a container here. So we have our gases in here. Nitrogen, hydrogen, and ammonia. And say we're at equilibrium. And then say we decrease the size of the container. So will increase the pressure inside the container. So now if we decrease the volume of the container, we're changing the concentrations. Because remember, concentration is moles divided by volume. So if we change the volume, we're changing the concentration of each species. But you can see here that if we change the volume, here the volume changing by squared, and here the volumes are changing by the fourth power. So this is going to change the value of the equilibrium constant. So we'll no longer be at equilibrium because the equilibrium constant has to stay the same value no matter what at a particular temperature. So if we change the volume, then we disturb the reaction away from equilibrium, and the reaction will have to respond. So if we increase the pressure by decreasing the volume, then you can see the pressure on the reactant side is greater than the product side, because here we have 4 gas particles on the reactant side and only 2 gas particles on the product side. So if we increase the pressure, from Le Chatelier's principle, this pressure will need to be relieved, and so the reaction can relieve pressure by going to the right. So we're going from 4 particles to 2 particles. So that's the way it can relieve pressure. So pressure relieved by the reaction going to the right. Then we'll increase the number of product molecules so that the equilibrium constant will go back to its original value. Because remember, we have concentration squared, concentration to the fourth in the bottom. So if we increase the concentration, the reaction will be away from equilibrium. Now, if I have the same number of gaseous reactants and products, the reaction can't relieve the pressure by going forward or reverse, and so there's no change in the concentrations that results as a change in pressure. Only when I have different number of gases on the left and right side of the equation. The next thing we can talk about for Le Chatelier's principle is, say we have reactants going to products plus heat. Say we have an exothermic reaction, or we have an endothermic reaction. So this is exothermic, and the bottom reaction is endothermic. So an example of an exothermic reaction would be like fire. If we start a fire, that chemical reaction releases heat that we can feel. An endothermic reaction requires heat to proceed. So heat would have to be on the reactant side. So now we can treat heat as a product or reactant. Say we had this top reaction, an exothermic reaction, and we added heat. Then heat can be thought of as a product, and so if we add heat, that's going to drive the reaction back toward the reactants to achieve equilibrium. Say if we add heat to the endothermic reaction, it's going to make the reaction relieve this additional reactant and go toward product. So this is how we can treat heat as a reactant or product using Le Chatelier's principle.